Hi, let me continue to my first part of the lecture demonstration. Let me say my screen real quick. So for the lecture, we are going to deal with the curve with the damn sideway curve, just like you can see here. So for that, I just have to go and do the code by import the library, define the function that this is the given one in the instruction. Follow X and Y condition. Here I set the range. You can either choose the range of your choice and set it and the Y corresponding to a variable. And here's in the logic for loss the original sideway and plus the fit waveform. Let me try to run it to let you see the indication of the sideway damn curve. Here's the shape of my sideway damn curve. Just like you can see here, this can later compare to the Desmos method. So let's move into the next part. Following this one, we have the noise curve. And for this part, I will ask to collaborate the following website and based on the previous code. Here is the one, the formula I was given by the instructor, and he did the same thing. So I have to check it here, run it here, and compare to the Desmos method in this part, plus the original sideway. Here you can see it's my curve with the noise cancelling. So let me try to compare to the formula in the Desmos. Sorry. This is the formula in the Desmos, so I have to follow in my code here to set the order variable to the exact number I pick in the code to have the corresponding answer. So you can see here, it's lined out on the tree in the y-axis, and I successfully generate the code and get the corresponding waveform based on enter the correct formula of function here. You can either change the variable here of your choice. Oh, of your choice here, the range as well, just like that. So next is the a pop-up using a curve with multiple variable from lecture 3. So here I was to write the Python program to generate a waveform with two independent variable. However, I have to try to find different scenario to set the curve. So let's move into the curve with multiple variable. So just like the usual library here in the lab code. So I have to import mask and numpy SNB. Make sure I have to base into this as well. So here is the XY range logic I was given, and I have to try to do it by myself. Here's the thing: the testing bar, the define function for test, the curve for with multiple variable with the format here. That means you have to provide it to pair of variable and start testing by using the test work as a command to test. Let me try to test. It will generate you with the five different scenarios to see the different and how can you choose the best fit for the function here. So here we go. I got find new function. Just like you see, this is my base function for the curve fit. So later they compare this scenario with this situation. So this is for 22, just like you see here. For this one, it's not working because I think it's too much saturation. However, it's happened to the same for the 3-5 situation because it does not really match with the curve fit, the plot curve fit. Yeah, this one as well. 6-4, the it's too last for it. This one as well. 32 is too much. 13 is too much as well. However, if you look for the 2-1, you can see it's approximately matching, so it's works best at all. So you can test by provide 5 different pair of variables here to check for each situation and compare them together to find the best fit for the curve fit knot. So next is the last part by the game design. So here I have to level the game design to the my own hack and twist implement 3 out of 4 option below. Different actor change the playing area and ask extra time to go faster. So let's me go into the format of this one. I have to do like usual game demo import pgz run py game pg0. Make sure I have this library available. So for the function this line draw the Pac-Man and ball on screen, I change the picture to my own Pac-Man with the size, the new size, but resize already. It's the size of the area. I can change it as well. And the time up is this time over. When the time running up, this means you lose HC 5% for the update. It's move the Pac-Man to pixel to the left if the left arrow is pressed, and the else is the logical for how you control the Pac-Man. And here's the time. I pick 10 seconds. So if it's over 10 seconds, you lose already. It's the screen of the emulation size and color. You have to change it at your choice. So let me try to run the game really quick. Oh, I have to restart the first. Okay, here we go. Here's the game you can see. So by clicking on it, you can hit the ball as fast as you can. If you over the time, you automatically lose just like that. And that's all for my game demonstration. Thank you for listening.